In the middle of the Cold War, the Soviet Union built a machine so large and so powerful that it could be detected from thousands of miles away. But for years, no one outside the USSR knew what it actually was. All they had was a signal, a strange, repetitive tapping sound that suddenly began appearing across radio frequencies in the 1970s. It didn't belong there. It interfered with civilian broadcasts, military communications, and even aviation systems. Airline pilots reported disruptions. Radio operators struggled to maintain clear channels. And no matter where you were in the world, if you were listening at the right frequency, you could hear it. Because of the sound it made, Western operators gave it a name. They called it the Russian woodpecker. At first, it didn't seem like much, just another piece of Cold War interference. Signals crossed all the time during that period, but this one was different. The signal was unusually strong, too strong for anything conventional. It would override other transmissions completely, forcing its way through frequencies that were supposed to be clear. And it didn't behave like a normal transmission. It pulsed rapidly and consistently, sometimes stopping without warning, sometimes shifting frequencies entirely. It didn't follow any known pattern, and that made it difficult to ignore. As more people started noticing it, governments began paying attention, especially in the United States. Because if the Soviets had built something capable of producing a signal like this, it meant they had developed a technology no one else fully understood. And during the Cold War, uncertainty was dangerous. Not knowing what the other side was capable of could be just as threatening as the weapon itself. At the time, both sides were racing to improve early warning systems. The biggest fear wasn't just attack, it was surprise. If a nuclear missile was launched, you needed to detect it immediately. Seconds mattered. Minutes could mean the difference between retaliation and total destruction. There was no margin for delay, and that made detection systems one of the most important technologies of the entire era. The United States had its own radar systems, but they were limited. They relied mostly on line-of-sight detection, which meant they could only see so far. Anything beyond the horizon was effectively invisible, and that created a dangerous gap. A missile could already be in the air, traveling toward its target, before anyone even knew it had been launched. Closing that gap became a priority, so both sides began experimenting with something more advanced. Over-the-horizon radar. Instead of sending signals straight out, these systems bounced radio waves off the ionosphere, a layer of the Earth's upper atmosphere. The signal would travel upward, reflect back down, and cover distances of thousands of kilometers. In theory, it allowed you to see far beyond the curvature of the Earth. Entire continents could be monitored from a single location. It was a major breakthrough, but it came with challenges. In practice, it was extremely difficult to control. Signals could scatter unpredictably. Atmospheric conditions could distort readings. And even small changes in the ionosphere could affect performance. What worked one day might fail the next. And that's where the Soviet system came in. The structure itself was enormous. Rows of metal towers stretching hundreds of meters across. Some sections reached heights of over 150 meters. It didn't look like a traditional radar installation. It looked excessive, overbuilt, almost experimental. Which, in many ways, it was. The system was designed to detect missile launches from across continents, but to do that, it needed power, a lot of it. Far more than most radar systems at the time. It consumed massive amounts of energy just to operate. And when it was active, it didn't just scan the horizon, it flooded the atmosphere with radio energy. That's what people were hearing. Not a message, not a communication, but the byproduct of a system operating at full capacity. A side effect of its scale and intensity. The stronger the signal, the more effective the detection. At least in theory. But that strength came at a cost. At first, the Soviets didn't acknowledge its existence. Officially, the signal didn't exist. Unofficially, it became impossible to hide. Radio operators around the world were documenting it, recording it, trying to understand it. Some attempted to block it, others tried to analyze its structure. And the more they studied it, the clearer it became that this wasn't accidental interference. It was deliberate. The signal had structure, timing, and consistency, which meant it had a purpose, even if that purpose wasn't immediately clear. Eventually, intelligence agencies connected the signal to a specific location, a site in northern Ukraine near the city of Chernobyl. There, hidden in the forest, was the source of the signal, a massive over-the-horizon radar system, later known as Duga. From a distance, it looked like a wall of steel, tall, dense, almost impossible to ignore. Up close, it was even more imposing. The scale of it suggested something important. something expensive, something the Soviet Union was heavily invested in. It wasn't just a test, it was part of a larger system. And for a while, it worked. The system could detect objects at long distances. It provided early warning capabilities, at least in theory, but there were problems. The signal was unstable, it interfered with other systems, and it required constant adjustment to function properly. Engineers had to continually monitor conditions and recalibrate the system. It was powerful, but not precise, and that made it unreliable. Sometimes it produced false readings. Other times, it failed to detect what it was designed to find. In a system where accuracy was critical, that was a serious flaw. At the same time, it was drawing attention. Too much attention. Because the stronger the signal became, the more noticeable it was outside the Soviet Union, and the more people started asking questions. Why build something this large? Why use this much power? What exactly were they trying to detect? And why did it seem so unpredictable? The secrecy surrounding the project only made those questions more intense. Some theories went further. There were rumors that the system was being used for more than radar, that it might have effects on the environment, on communication systems, even on human behavior. Most of those claims were exaggerated, but they reflected something real. The system was operating at levels that hadn't been fully tested, and the long-term effects weren't completely understood. It was new technology being pushed to its limits in real time, and no one could say with certainty what those limits were. For the engineers working on it, this created a constant challenge. They had to maintain a system that was both powerful and unstable. They had to keep it running while adjusting for changing atmospheric conditions. And they had to do it under pressure, knowing how important early detection was during the Cold War. But even with those efforts, the system never became fully reliable. It was always unpredictable, always difficult to control. Then, in 1986, something happened that changed everything. The Chernobyl nuclear disaster. The explosion and meltdown at the nearby power plant forced the evacuation of the entire area, including the radar facility. Workers left. Operations stopped. The system was shut down and never fully restarted. Almost overnight, the signal disappeared. The tapping stopped. The interference ended. And the Russian woodpecker went silent. After years of being heard across the world, it was suddenly gone. For years, the site remained abandoned, hidden behind the exclusion zone, untouched, frozen in time. The massive structure still stood, but no one was there to operate it. Nature slowly began to reclaim the area. Metal rusted, vegetation grew around it, and what was once a highly active military installation became a relic of the past. Eventually, as more information became available, the full picture started to emerge. The system wasn't a weapon. It wasn't a mind control device. It wasn't anything as extreme as the rumors suggested. It was a radar system, an ambitious one, an experimental one, but ultimately, an imperfect one. It represented a moment in time when both sides of the Cold War were pushing technology as far as it could go, sometimes beyond what they fully understood. The Duga radar was part of that, a system built to solve a very real problem, but one that came with unintended consequences, interference, instability, and global attention. It showed how difficult it was to control systems operating at such a large scale, and how even successful experiments could create new problems. Today, the structure still exists, rusting, silent, standing in the forest near Chernobyl. It's one of the largest abandoned structures in the world, a reminder of how far governments were willing to go in the pursuit of information, and how some of the most powerful systems ever built were never meant to be noticed by the world, until they were.